In the last class in sources of energy, we studied about alternative source of energy and why alternative source of energy required in today's life and all we studied in the last class. So I told the different names of alternative energy also. So here it comes solar energy, nuclear energy, geothermal energy, tidal energy, ocean energy and wave energy. So today let us start to discuss one by one, and the first one, let us start from solar energy. And we know that the main source of solar energy is nothing but sun, right? So in today's class let's start from solar energy. We know that energy is the ability of an object to do some sort of work, and there are different types, that is kinetic energy and potential energy, right? Now we'll concentrate on solar energy. The main source of solar energy is nothing but the sun. Hence, the light energy and heat energy from the sun are known as solar energy. And here we can observe that we'll get directly the energy from sun to earth. Now we can, or with some different techniques, we can use those energy, right? Now solar energy can be converted into useful form of energy. For example, we can say that solar energy can be converted into electrical energy, and electrical energy can be converted into heat energy, kinetic energy, potential energy, etc. So overall we can say that solar energy is nothing but it's an renewable energy, and it is a cheapest form of energy. Sun has been radiating energy from the past 5 billion years and will continue to do so at the same rate for another 5 billion years or more. And now let us see the amount of solar energy, how we will receive, in what quantity we will receive from sun to earth atmosphere. How solar energy reaches the earth. The solar energy reaches from sun to outer edge layer of earth atmosphere with some quantity, and that is called as 1.4 kilojoule per second per square meter, or else we can call it as 1.4 kilowatt per meter square, and this is called as solar constant. Now there is one activity 14.5 which you should read in the textbook related to the solar energy. Now let us see some of the solar energy devices, that are solar cooker, solar water heater and solar cells. Let us see solar cooker and solar water heater. These two operates only based on solar energy, that is the from heat energy from the sun. We know that solar cooker looks like this, and we already know that black surface absorb more energy than other surfaces, right? Therefore solar cooker use this property by coating their inside with black color, and they use reflecting surfaces like mirror to focus the sun's rays, and the device is covered with glass plate. It is covered with glass plate. This is because to establishing the greenhouse effect. So to avoid greenhouse effect, this glass plate will trap the heat inside the cooker only. It won't leave any harmful gases outside this device. So solar cooker which looks like this and which work with the solar energy. And next we have solar cell. We know that a device that converts solar energy into electricity is known as solar cell. Once again I will repeat. Remember, solar cell, this is a device that converts solar energy into electricity. So remember, here using semiconductor devices just like silicon, we will use solar energy cells. And this solar cell is also called as photovoltaic cell. Remember, photovoltaic cell. Now as I told, silicon used in this cell. Now why silicon used means the electrons in a silicon will absorb solar energy and they will create high voltage which acts as a semiconductors. So here silicon is used, and silicon is little bit costly only, but it is used in the solar cells. Now we know what is solar cell, but remember a single cell produce very small quantity of voltage, but in order to get high voltage for practical users, a large number of solar cells connected in series, and that is called as solar panel. I will repeat again. Using solar cells in a large amount, they will connect one to another in series connection, and that will make solar panel from which we can gain a large amount of voltage. And this is called as solar panel. Now let us study about solar panel. Now we know about solar cell and solar panel. So here they have some advantages and disadvantages. When it comes to the advantages, no moving part. The solar panel is something which is fixed. No need to move anything, which acts as an advantage and require little maintenance. So there will be no expenditure for maintenance purpose and all, very little maintenance, and can be set up in remote areas without the hassle and expenses of transmission lines. So there is no transmission required. If you set up a one device with the panel, the heat energy is collected and we can use it as a electrical energy. We know that sun will get only in the daytime. So in the daytime it will connect the energy, and in the night time we can convert that into electricity and we can use it as a light source, right? So here we can observe in many areas this one. Hence, these are acts as advantages. When it comes to the disadvantages, it requires special grade silicon. As I told, solar cell, they require silicon which acts as a semiconductor and which is not easily available. And next disadvantage is usage of silver for interconnection makes it expensive. And so both disadvantages is based on the element silicon. The first one is it is not easily available, and the second one is usage of silicon will be more while interconnecting them, so it will be acts as expensive. And when it comes to the users, we can use these solar energy devices in traffic signals, and we can observe them there in calculators, and next artificial satellites and space probes, and nowadays we can observe solar car also. So this acts as application as well as users. Now we studied about solar energy. In that we know about solar cooker and solar cells, and in solar cell we know about solar panel and its advantages and disadvantages and its uses. Now we have the next topic is energy from the sea. Energy from the sea. So here we know that in a sea, ocean and in some of the water bodies, all of these are the good sources of kinetic energy and potential energy due to the immense volume of water as well as the motion of waves. So from the ocean or from this source of sea, we'll get three types of energy. One is wave energy, one is tidal energy, and another one is ocean thermal energy. So I'll repeat again, there are three types of energy from the ocean, that is tidal energy and wave energy, and one more is ocean thermal energy. So now today we will understand all the three. So let us start with tidal energy. So here we have tidal energy. Tides, these are the variation of movement of water in an ocean, upward and downward movement of water, and then we'll get the tides. And the movement of water variation, that is upward and downward, happens due to the gravitational pull between sun to moon. So because of gravitational pull, there will be a motion or there will be movement of upward and downward or rise and fall of water level. So from that we will get tide, and from this process the tide energy is obtained, and these are the plants or the devices to get tidal energy. There will be almost set up coastal areas near the sea or near the narrow opening of a sea. Dams will be constructed and there they will be placed. So there are some 3 to 4 techniques to obtain this tidal energy. In that mainly, just imagine how we studied about wind energy. The same things they will plot under the water, and turbine will start to rotate whenever the rise of water takes place up and down. From that they will connect the tidal energy, and this is all about tidal energy. So here I will repeat. So here tides are variations in the level of water due to the gravitational pull of the moon. The phenomenon of rise and fall of water level gives the tidal energy, and tidal energy is obtained by constructing dams near the narrow opening of the sea. When the tide set in, it moves the turbine which directly produces electricity. Now look at this clip, you will understand or you will get an idea how we will obtain tidal energy. Now we know that how tidal energy will work, right? Due to the gravitational pull between the sun and moon, there will be upward and downward movement of a level of the ocean, and these we can observe locates only in the coastal areas, and tidal energy will be more with the surface level of the sea, that is high tide. And there are different techniques which showing like this to obtain tidal energy. Let me show this last one, that is tidal turbine. This is similar to wind energy but below the sea. Here turbine starts to rotate, and with the help of generator the electricity will produce, and this is how electricity produced from tidal energy. We know when we observe the ocean or the sea, we will get a large number of waves, right? So there will be large number of waves, and here wave possesses a good kinetic energy, and using this source of kinetic energy we can obtain or we can produce electricity. And the next is, we know that wave produces wave produces when strong wind blows. If the blow of wind is high, then we will get the higher waves. So using this idea or using this situation where we will get the strong waves, they will design the devices and they are already placed under the water. So where we get the strong waves. So with strong waves, the design setup will gain some energy, and there will be some motion of magnet under the water. Due to the strong wave, it will start moving up and down, and with that technique it will start collecting the electrical energy, and with the underground wiring or something else they will collect the electricity. So wave energy again, it is nothing but the producing electricity with a stronger waves. And here we have a look at this clip, and you will get an idea how it will work under the sea. So here it's important to get higher waves. When we get higher waves, the device which is set up, it will start to flow up and down along with the wave, and along with that the device which is set up to move up and down, due to that motion the current will be start generating and started to, and there will be not only one setup, there will be number of setups which are connected to next to one another. So this is about wave energy. Now look at this clip. We know that waves are produced by a strong wind blowing over a sea. Now the devices are already set up to gain wave energy. When the high waves are produced, that device started to float, and when it is floating there will be a coil which is connected to that, and that coil of a magnet will start to move up and down as the waves are strong. And next the produced current will be stored below with a foundation, and the wave energy machine is securely anchored, and these are connected to the cables, and we'll be having a large number of same devices, and electricity is produced with this technique. So next here we have ocean thermal energy. So we already know the concept of thermal energy. So imagine we have a sea or ocean. So if this is the surface, and just imagine we have in depth also inside. So here what happens, the topmost layer of a sea, this will, due to the direct radiation from the sun, it will be almost warm, where in the topmost layer of the ocean, the water will be warm due to the radiation from the sun. So now what happens inside, deep inside the ocean level, the water will be here cold. So here the water will be cold. Now we got to know that in the surface the water will be warm and inside the water will be cold. Now to obtain this ocean thermal energy, there should be minimum 20°C difference where in the temperature. So and the distance from the topmost surface layer to and the inside the cold one, it should be almost 2 kilometers. So there are two important points. So one is a warmer and inside in depth there will be one, the water will be cold, and the minimum temperature difference between this cold water and warm water should be above 20 or above 20, and the minimum distance between this warm and this cold, the level of these two waters should be 2 kilometers. With only this important points, ocean thermal energy can be produced. Now this is our picture. So in the topmost layer only we will get warm water. So here they will connect one pipe and another one we have here, right, 2 kilometers. Here they will connect another pipe. So what happens here? Here they will take volatile ammonia, that is NH3, and they will start to heat that one along with the warm water. Then that volatile NH3 ammonia start to vaporize, and that vaporize will be connected to turbine, and here as usual turbine started to rotate, and here with the help of generator they will start to produce electricity. So this is how the warm water acts to boil NH3, and that the vapors will join with the will rotate the turbine, then along with the generator electricity will be produced. Next we have one more connection, that is from the cold water. So the role of cold water is used to condense the vapor and turn it back into again liquid. So the role of cold water is to condense the vapor and again vapor back into liquid. So this is the technique how ocean thermal energy looks. Now we have a clip, just look at that one. Look at the picture, there is red and blue pipe which shows the connection between warm and cold water and with minimum 20° temperature. And look at this setup, look at this condenser part which is connected with the cold water. Cold water is used to condense the vapor back to liquid, and here we have the connection of warm water, and it is used to boil volatile ammonia to form vapor that move the turbine, and hence there will be production of electricity. And this is the setup of how to produce ocean thermal energy. Now students, in today's class we learned about solar energy, tidal energy, wave energy, and one more is ocean thermal energy. So all are important, so understand one by one and make sure to write your own points based on these theories. As usual, write on the notes and send the homework before 5 o'clock.